Okay, technology finally working. Classwork 7.4. I love the word sinusoidal. Anyway, sinusoidal applications. And this is working only with multiplication or division inside the function or outside the function, with the way that I have these two y values written, just to point that out. So now, vocabulary words, period and frequency. Period is a math word. Frequency tends to be a physics word. And so I'm just going to head over here and know that the period is the length of time it takes to complete one cycle, but frequency is the number of cycles per unit of time. And it is the same thing as the reciprocal of the period. The unit B in this case is not an issue. B is looking at, or wait a minute. No, I'm sorry. Start again. Start what I just said again. Mondays. The B is the number that is multiplying to the T. So that's the number that graphically will either squish it horizontally in or stretch it horizontally out. If the number B is a number larger than 1, you will actually squish it. If it's between 0 and 1, you will expand horizontally the graph. And T is time. Normally when we look at the graphs, I've been using an X instead of a T, but here I'm using the T instead of the X. And hopefully, is everyone pretty clear about that then? Usually I put X where the T is, but right now I'm just using T for time, especially when I'm dealing with applications. So the X-axis is going to be the T-axis for right now. So then I've got a first example, and this is just, part of this is introducing the new vocabulary words and bringing it into a pretty standard physics problem. So we've got a weight right here on the end of a spring, and the weight is bobbing up and down on the end of the spring. Now, this is assuming an undamped system, which basically means it's not going to lessen its height over time. It's just going to keep going, assuming that I don't have all of the natural forces acting. So basically, we're in a vacuum, and it's being moved, and so it just kind of keeps going down 5 units, up 5 units past the center. But it's a total of 10 units that I am vertically bobbing between. And so now let's read all the details. The range of the vertical distance is in centimeters, 10 centimeters. And we're going to assume the equilibrium, which means the at-rest position, to be 0. So what I want to imagine is this being the y-axis, where I have 0, 5, and -5. And I just realized I should probably write that in a different color and also move it over to the side. So I have 0, 5, and -5. As time takes place, the x-axis is going to just kind of move, and I will see this vertical distance going up and down as time heads to the right. Now, the time that it takes for the weight to move from its maximum displacement to its maximum place. Read it again. The time it takes for the weight to move from its maximum displacement above zero to its maximum displacement below zero and back again is 4 seconds. I realize that's difficult to read, and what that is trying to say is the time it takes for me to start at the very top and then move down to the bottom and then move back up to the top. The amount of time for this weight to move from this position down and back up. That is 4 seconds. So with that said, what is the period of the system? The period of the system is 4 seconds because the period is just how long it takes to make one cycle and then repeat itself every 4 seconds again. What is the frequency? 1/4. And basically that's telling me that in 1 unit of time, in 1 second, I will only be going through a quarter of the cycle. And that's what the frequency is explaining. If you take a look at what I have written in the answers for that, I want to point out that I used hertz because that is the physics unit that gets used with frequency. And I put in parentheses that hertz means how many cycles per second. I'm not going to push all the physics on you completely. So if you don't want to deal with the unit hertz, I'm not going to push that. You can just say that the units of 1/4 are cycles per second, 1/4 of a cycle per second. But if you're familiar enough with physics that you feel more comfortable using hertz, then you can use hertz. But I'm going to leave it there as far as that particular unit of measure is concerned. All right, now for part D. Assume that time begins t equals 0 when the weight is halfway through moving up. So that means that what I drew over here is not that, and I'm going to erase it. And fantastic, I erased more than I intended to. Okay, if I am halfway through moving up when time is 0, then that means that I am at the equilibrium point, the center, and I am still in the middle of moving up. And understanding the way this cycle will take place from there, I know that in 4 seconds, it's going to go through 1 full cycle. And I'm going to have to change that. There we go. So 4 seconds to go through 1 full cycle of from the center going up and then coming back down to the center to finish half a cycle, going down to the very bottom of -5, and then going back up to the center. Now, can you see that this is a sine graph because it has started in the middle? And that's why I have written down that you're going to write an equation of the form y equals some number a multiplied by the sine of And then some number b needs to multiply to the t. And this is giving me the weight of the height above or below the at rest position of y equals 0. So I'm going to give you a moment to see, can you figure out what is a, the number a? And recall that that number is multiplying outside the function, so that's the vertical stretch. And correct, the vertical stretch is 5. And it's going to be a positive 5 because sine is starting at the center and moving on the way up, and that's what a positive sign would do. I'm going to temporarily erase this graph, and I'm going to show you that if it was negative 5, then the graph would have looked like this. That would be a negative sign. A negative sign begins at the center but begins by moving down. A positive sign begins by moving up. I'm now going to undo back to the graph. All right, so I have a positive 5 is my a number times the sine of something times t. Now, there are different ways you can go about this. Know that if I look at the function of 5 sine t without the b being multiplied, that for that graph, this x-coordinate would be at 2 pi. So the normal end of a cycle, the normal period of a graph, is 2 pi. The period of this graph is 4. When it comes to what number is it that is multiplying to the input x, or in this case t, if you take where things normally are, and instead of multiplying by b, you divide by b, you will get where things currently have been transformed to. And that will allow you to find what your b is. So what does this end up making our number b? Mm-hmm. 1/2 pi. And so I can write it as times pi over 2. Another correct way to write this that means the same thing is sometimes people will write pi t over 2. And it means exactly the same thing. All right, with that, we now move on to let's graph that equation, but on this grid. So I want to see that I have a full cycle with sine from 0 to 4, and it hits its highest y value. Oh, wait, is that the right thing that I was saying? Yes. It hits its highest y value of 5 when time is 1 second later. 3 seconds in, it hits its lowest y value of -5, and then it will repeat the cycle. Yeah. So ultimately what we're going to be doing with our application problems is first just trying to figure out what in the world the problems are saying. That's the first thing. But then we're going to be drawing graphs and making equations. Those are our two biggest goals, are trying to get to the point of making an equation and drawing a graph. I'm going to go ahead and show the classwork answer on that. And that shows more than just one cycle. And these, it's really important to take a look at the fact that trig really brings in some applications that are real applications. If you think about a lot of applications that math tries to do, sometimes they're just almost a joke when it's like, you know, I have $5, 10 of them are, you know, I have so many coins in my pocket. What are the coins? You know, some of them are just like absurd and like no one would ever bother solving that problem. But there are a lot of math problems out there that are very important in application and have some good examples that we can actually start with in a high school level of math. There's only so much you can do with decent applications with a high school level of math. And I try to stick with what is reasonable in an application for you to do with the math that you know. All right, now, this is similar to the Ferris wheel, but I instead have a water wheel and a certain level of water, basically. And what you need to understand about this next example is that the water level is y equals 0. So when I later attempt to draw a graph of this equation, I want to see that y equals 0 is this water level. And considering that the radius of the water wheel is 7 feet, and that the distance from the center of the water wheel to the water is 6 feet. That means that it goes 1 foot underneath the water. So I'm going to mark a -1, and that is the lowest y coordinate of this function. What is the highest y coordinate of this function? Mm-hmm, 13. Because with the radius being 7, when I look at that going from 6 feet above the water level, it's 7 units more, 13. And now let me just read the problem. Suppose that the water wheel in the figure rotates at 6 revolutions per minute. Now, 2 seconds after you start a stopwatch, point P, here's P right here, and it's point. Point P on the rim of the wheel is at its greatest height of 13, but that's 2 seconds. Was it 2 seconds? Yes, 2 seconds in. And it is at its peak of 13. So let me tell you what you should do in this case. It is easier to have a cosine graph starting at 0, analyze it, and then shift it 2 seconds to the right. So that's what I'm going to do as I look at this problem. I'm going to remember that it starts 2 seconds later, but I'm going to begin creating this, and it's going to be easier for us to play with if I think about the idea of cosine of it being at its highest when it's at time 0. And I just, yeah.
How do you know it's a cosine graph?
Good question. If you are looking at starting at a highest point or starting at a lowest point, you want to use cosine. If you're starting at a center point, you want to use sine. And honestly, they're interchangeable. It's just a matter of if you don't have that horizontal shift, then you really want to go with at time 0. If it's at the highest or lowest, you would rather use a cosine function. If at time 0, it's at the middle, the center, then you want to use a sine. But with a shift, you're going to have to shift it no matter what, so you can actually go with either. But because this says 2 seconds later, it starts at its greatest height, I'm going to focus on cosine and then just kind of draw, but this is not accurate to scale, but this is kind of an essential beginning thought. Now, if it does 6 revolutions per minute, and I want to look at basing the frequency on number of seconds. What do I need to, or, okay, I think I answered that question. So what do I need to do to change 6 revolutions per minute into a certain number of revolutions per second? Mm-hmm. And the way I'm going to write it is this. I have minutes in my denominator. I want to get rid of minutes in my denominator, so I put it in numerator. And I want it to turn into seconds. And I have for every 1 minute, 60 seconds. And the minutes unit-wise will cancel, and I will then have revolutions per second. And 6 times 1 over 60 is 1/10. Now, what was the meaning of frequency? And then, so there are different ways to approach it. It's 1 over the period of the graph, and it's also the number of cycles per unit of time. So if the frequency is the number of cycles per unit of time, you want to realize that every revolution of this wheel is 1 cycle. So the frequency is actually the number 1/10 if I want the frequency to be based on seconds. And you can say cycles per second. And I want to real quick come back over here. Hertz officially is cycles per second. So I can go ahead and put hertz on that if I prefer. But you can write either 1/10 of a cycle per second or 1/10 of a hertz, whichever you prefer. They both mean the same thing. So that's part A. Part B. How many seconds have passed when point P reaches its maximum height for the first time? That question is just trying to get you to recognize that it said 2 seconds. So the answer to this very first question mark is 2 seconds. The next question is, what is the maximum height, which I've asked you earlier, and that would be the 13. And that's part B. Part C. How many seconds have passed when P reaches its minimum height? And the easiest way to do that is to ignore the 2 seconds temporarily. And let's look at, bring in the frequency or the period, whichever viewpoint you want to bring it in from. So we want to know, hold on, I just lost my place and I need to underline so I don't lose my place of where I'm looking. I'm asking seconds to reach the minimum height. What do you guys think? Do you think you have an answer? And the minimum height is -1. How do you know it goes to -1 under 0? And yeah, Lucas is answering it right there. It's the issue of the radius being 7 feet and the center of the wheel is located 6 feet above the water. There are probably better ways that this could have in words been presented. Okay, so what gets you to saying that it takes 7 seconds to get to a minimum height? Right. So one way you can look at this is because the frequency is 1 divided by 10, that means the period is actually 10 revolutions per second. That means that it will get halfway through its cycle in an amount of time of 5 seconds. And by the way, I'm expecting the majority of you to feel absolutely 100% lost right now. What you're doing right now is you're paying attention the best you can to make sense of bits and pieces as we go along. What the majority of you are doing right now is making sense of what I'm telling you as we go through the problem, not necessarily you being able to come up with these answers on your own. Right now, you're just listening. For some of you, it's making sense, and you're a little bit ahead of me. But I'm expecting for a lot of you for this literally to be just extremely difficult and you feel lost. Don't worry. That's why I've got scheduled a bit of time to keep going over these things. And as we go further along, I'll also kind of bottom line it for you of look for this, this, and this within your word problem and help you out with that. So just relax, listen. So if I have 10 revolutions, sorry, I just realized I wrote that wrong. 10 revolutions, period. No, what am I saying? Uh-oh, I lost somebody. Wait, this class? Oh, good. Oh, I'm glad. I'm glad. I just lost my place again on what I was asking. I have got to tell you, today I've had such a hard time concentrating and focusing. I'm trying to stay focused and keep focused. And now I'm just like, la 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 la. 10 seconds is how long it takes to make one revolution. Okay, boom, done. Now, if it takes 10 seconds to make one revolution, then it's going to take 5 seconds to do half a revolution, which will cause it to go from its highest to its lowest. Then when I add in the fact that it started 2 seconds, that it was at its highest value 2 seconds after starting the stopwatch, I have to add 2 seconds to the 5 seconds to get 7 seconds. Then what is the minimum height? And again, that is -1. So now, the next question, part D. How do you know how many revolutions for feet? Oh, because it's the issue of the diameter is 7 feet. So for every time that you get one full rotation, every time you get one full rotation, the and this would be easiest if I say when it starts with point P up here. As I go through the first rotation, if I'm thinking about starting here, it takes me a certain amount of time to go from this point to this point, and that is a change in distance of 14 feet. Okay, I see what you're saying. The revolutions are actually looking more at the issue of seconds than with feet, because the revolutions, how often the revolution takes place, is affecting how long it takes for the cycle to occur. And that's in a way separate from looking at the Y value, which is in terms of feet. And so the first thing is we have 6 revolutions per minute. And when we got from that was that we will get 1/10 of a revolution for every 1 second. So then the feet only come in, though, when I understand that whatever time it takes me to go one full revolution, that is telling me the time it takes me to travel a vertical distance of 14 and another 14 feet. If that makes sense. The feet is dealing with one issue, but the revolutions and the seconds are dealing with the time issue. And I'm going to keep, if you look at what I wrote down for my plans for the next few days, I know that tomorrow I may need to re-go over some of this and help you. Yes, yes, half a revolution is 14 feet traveled. Mm-hmm. Let's see. Next question is, how many seconds have passed when point P reaches its maximum height for the second time? If it takes 10 seconds to make one revolution, and I actually started looking at the highest point 2 seconds into my stopwatch, then I need to add those 2 seconds on to get 12 seconds. So it takes 12 seconds to reach its maximum height for the second time. And hopefully what this is helping you to do is understand what the nature of the horizontal shift means. Because the horizontal shift of 2 seconds really just allows me to change what time I start looking at. But it's actually a lot easier if I don't start looking at 2 seconds, or I mean, don't start the height 2 seconds later, but to actually start the timer 2 seconds later and look at it from there. It is always easier to, I have found it easier with word problems to do the horizontal shift at the very end. And before I hit the end, to focus on it starting at time 0 at either its highest, its middle, or its lowest point. That little shift where you have to add in messes people up really badly. And I want you to be aware that I realize that messes. I do have a homework assignment that you can start on, but I'm not going to assign it for being turned in by midnight tonight. And I'll go ahead and I'll put that up right after class. Oh my goodness, I only have 4 minutes left. And that's why, let me see how many more examples I plan to have. Okay. So what you're expected to do here is now plot the points that you have on the graph. And I'm going to say that some of you are going to need a lot more guidance before turning the homework in, and I realize that. I will allow you an extra day if you need it on this classwork. And I will put up the homework. I'll put up all the due dates so that you're clear about when you absolutely have to get things turned in, but you can turn them in early. Now, coming back over here, I'm now plotting some of these points to help me come up with an equation. So at time 2 seconds, I am at my highest value of 13. Then at time 12 seconds, I'm back at that highest value of 13 again. Now, I also know that at time 7 seconds, I'm at my lowest value of -1. By getting those 3 points plotted, I can see a little bit better what I'm working with. And I'm going to draw a dashed horizontal line for the midline. The midline is going to be halfway between 13 and -1. Now, if I wanted to make the very bottom of the wheel be 0, then this would be far easier. If the bottom of the wheel was y value 0, the top of the wheel would be y value 14, and the center would be y value 7. But all I have here is a vertical shift down 1 unit so that I can make it that the water level is deemed to be the y level of 0. But sometimes, again, that vertical shift and horizontal shift is actually easier to deal with in the end. So what I did was I looked at if this low value is 0 and the high value is 14, then the midline is 7. But with everything moved down 1, that means the midline is 6. And the bell is about to ring on me. And you know that it's going to hit the midline halfway in between when it's at its highest and its lowest. So halfway between time 2 and 7 is what time? Oh yeah, there are a variety of ways. Right, right. In this situation, we actually don't need to know the x values where it's equal to 0. My concerns are more where does it begin a cycle and end a cycle and halfway through the cycle, and then also the midline middle points. Those 5 points are the important ones. And oh, absolutely. I guess the time just ran out on me. So I'll give you another day if you need, and I'll also post some stuff up. And